Okay, so let's check one-hot encoding and see what do we use it for. So let me give these two scenarios. Naturally, there are things that nature has ordered them, but as we are growing and civilization is coming up, we are realizing that no, that order is not or is no more necessary. For instance, in most instances, people feel that men come first before women. It's not like that. In most instances, people think that bigger things must come before smaller things, or maybe big one followed by medium followed by small. You see, but in real data science, maybe the small thing could just be a description, but that does not mean that the the small or the medium or the large has some kind of ordinality. I mean, like ordinal data, like the order of how the things are arranged. So it is because of this that in machine learning, people have decided to, introduce what is called one-hot encoding to make sure that the categorical data, like I have just mentioned, like sex, like color or maybe sizes and whatsoever. In the case the sizes are considered as categorical data, like small, medium, and then large, then we don't see them as ordinal data, or we don't treat them with ordinality. So how do we do that? You need to transform that data into what is called the binary, so that it will be represented by either 1 and 0, 1, 2, 2, 3, and then in that order. So let's look at briefly how to be able to do this. But this is basically why one-hot encoding is very important. There are three ways to be able to do that. Let me try and see if I can show us how to be able to do that. I don't know what, well, yeah, so let me pull up this, and then, yeah. So I've already written some few things here. And so let's look at how it is. Maybe when I'm typing, I'm told that when I'm typing, it makes it a little bit clearer. But let's assume that you have these two categorical data sets. Let's say I have people and their names. Let me just say people. What is it? We have people here. Why not call them like lecturers? Yeah. Okay, well, lecturers. And then I'm just going to create, let's say, a data frame. And then, so I have my data frame here, which is there. And so I'm just going to give them names. So let's say I have their, what each of them will have a name. And the name, let me just create some few of them. So I start with my, then yeah, give me a minute so that I can just do this. But I don't usually want the video to be too long, so that is why. And so I have another lecturer called Dukes, like I'm saying. And then let's say I have another one called Uju. Then I have another one called this way, one Duke. Maybe another one called maybe Tanjong or something like that. So that's for their names. Now let's look at their, I can go out of that and I'll create their marital status, something like that. So I'm just going to say M status, M underscore status, which means marital status, and it's a variable I'm creating. So I'm going to use this, and then I'll simply say, maybe starting with myself, I will say, I'll just give it something like single. Then the next thing I will just say is, let's say I'm married. Maybe the next person, let's look at it. Maybe the code is becoming quite long. I can just file it from here, and then I'll come and continue from this place. And so maybe the next person, let's say, is separated. And then let's say maybe the next person is, let's say, divorce. And then let's say the last person, it should correspond. I'm creating a data frame, so I cannot have one row or one column having more entries than the other. 1, 2, 3, 1, 2, 3, 4, and then the last one. So let me also say that one to choose to marry. Okay, so I've just done that, and then let's look at, maybe we'll come here, and then the last one, let's look at their body sizes. So I'm just going to create something called body so that I'll be able to is small. This person, let's say, is big. This person is, let's say, plus size. And then the other person, let's say, is lanky. And then maybe the other one, maybe let's say, is medium. Yeah. So when I do this, maybe I can run this and see if the code is properly written. So I can just have a look at the lecturers. Then you can see that I've created the data, which is now seated around here. As you can see it here, maybe I should brush this off and then run it all over again, and then you see how that looks like. So I have a name here, the marital status, and the body size. Now, what I was trying to explain is, if you use this kind of data to be able to do any machine learning, it's automatically going to make it look as if the people who are classified as small are actually small in size, or it's going to order them. It's going to allow the data to order from plus size to the big, to the medium, to the small, and then to the lanky. But actually, it's not. The data is not an ordinal data, so you cannot put it in positions or like having some kind of order. So that is what one-hot encoding is able to disabuse, to make sure that you don't have all these things. So to be able to make sure this thing doesn't happen, you have to make sure you change all this categorical data into a binary data. And the process of doing that is what is called the one-hot encoding. So let's try and see how that works. There are several ways of doing that. We can actually use a package called keras and use this function called toCategorical. That's one way. The second way is to use a dplyr package and then use the mutate function to be able to do that. And of course, the last one, we can also use the pivot wider function to also be able to do that. So I'm trying my keras, but it's not installing. I've tried that. You can see I've tried to load it, but it's not loading because it requires some kind of Python before it will be able to work. I have to have some Python installation and TensorFlow, but in this case, I'm unable to do that at the moment. So let me do the first two, and then you look at how that works. So this is my data frame. So if I come here, I will simply come and say lecturers. If I have lecturers like this, then I'll use the dplyr function, package. That is where I can have this pipe operator. So it's actually percentage a greater than percentage. It means I am piping greater than percentage like this. And then I'll simply enter and say I am mutating. And so I use the mutate function. Okay. So what am I mutating? So this is how we are able to use this particular function to change the one-hot encoding that I'm talking about. Now come and look at what I'm talking about here for the purpose of time. So I pick the data, let's say from here, I mutate it, and then I give it the variable, and then I am going to, anyway, like when I'm typing, it makes sense. So we have already seen what is this? Okay, the marital status here, and then we have single married, divorced, and whatsoever. So I'm going to pick the variables or the categories here one after the other. So let me pick single in the first place. So I'm going to say that single, and then I'm going to say single is now going to be like a variable itself, and I'm going to use the function called if else, and then the if else is going to say that I'm going to look at a single column and say that if else, you see that I've said if and then else, then I'll say m, so it's m underscore, that's the marital status, m underscore status, that comes if it is the same thing as single. If it is the same thing as single, so we put a single in double quote. If it is the same thing as single, then what should we say? We should say it is 1. If not, we should say it is 2. And then that's all. I could actually leave it at this point and then run it, and then you will see it's going to create a new column called single. And then in that case, you will not be seeing something like what is it, the single as a variable or a column header with zeros and then ones, or 1 or 2. I don't personally like using. So let me run this code without, you see that I have not added anything yet, but you can see that a new column has been created, which is now called single. And then under that single, you can see I have 2, 2, 2. It means all the people there are single, and that's what I'm talking about. So what is it? It's either 1 or, so what is happening here is that the single here, not everybody is single, but they spelled the single with an uppercase letter. He has spelled it with a lowercase. So the function couldn't find this particular single here. So he decided to code all of them as what? 2. Now let me come back here and then change this to the way it was. And then if I run it again, you now see that some will be 1, 1. So as you can see, it's better now. So some are 1 and then 2, 2, and then it means the first person is not married, is single, and then the rest are married. That's why they are 2, 2. So now this is how we are able to encode it, and that's the first one. So we could actually come out here and then pick the other variable. What was the next variable? Then we can look at married. Married again like this. We create it as a new variable, and we come and say that if, and then we say else, the if else listen. So we simply say if m underscore status like this is the same thing as we say married. So what should we say? We should code it as 1. If not, well, we should code it as what? 0. We are done. So here I'm going to use different coding techniques to make sure that it's not always 1 and 0. No, it can be 1 and 9 and whatsoever. So you see that the first one I made it 1 and 2. This one is now 1 and 0. I could have made all of them 1 and 0, 1 and 0. So we move to the next variable. So now that's what separated. Separated. Okay. And then we are saying that I think the code is becoming too long now. So let me so with the separated, we are saying that separated if is equal to, and then we are saying if else like this, and we are saying that our m underscore status like this is the same thing as you put into, when we say separated. So what code should we give it to it? So we are using a function called if else. So if it is true, give it 1, else you should give it 0. Okay, so here I'm saying that if the marital status is equal to separated, then what should we code it? We can code it 3. If not, we should code it what? 7. And then that's all. So far, this is how we are able to do one-hot encoding. Let me run the code and then you see that I've created how many so far? I have created another one. So you can see 1 and 2. 1 means single, 2 means married. When we got to marital status, 0 means not married, then 1 means married. Then when we got to separated, we have 3. It means separated. 7 means they are not separated. So this is how we are able to do one-hot encoding. But there's another way of, we able to do one-hot encoding. And then I will show that way momentarily. We are going to use the same thing, but this time around we're going to use a function called the pivot wider function. It is found in the package in R called the tidy R. So let me try here and load that particular package. So it is called tidy R. It's actually tidy R. Yeah, so it's here. So I just load it. Now that one, it comes with and then for the purpose of time, so I'm going to so here we are saying that I have some I have lecturers, and I want to use one-hot encoding to change their marital status and then their sizes and whatsoever. So I'm going to say create a value and assign that value maybe either 1 or 2 or 3 or whatsoever. Now later on, I will now use that particular value to be able to do the encoding at once. That way, it is way shorter than the other way around. For instance, if I come here, I will simply say I have my lecturers, okay, like this. So I have the pipe operator as well, greater than like this. And then I will come again and say mutate. And then the mutate function, I am going to create a variable called value. And what value am I giving to it? I'm going to give it a value. I can give it 1 or 0 or something. Then let's say I'm going to give it to a value 3. And that is it. So now, without anything, when I print this, you're going to see that a new column will be created called value. Okay. So if I run this, you see that a new column has been created called value. So because this new column has been created, I can now pipe that value into another set of the variables I was talking about. I'm just going to use that one as my set target to be able to transform the other data into whatever that I wanted it to do. So let me now pipe it again. I'll use pipe here, greater than, and then another pipe here. Okay. And then in this case, if I'm piping again, it's always good to enter. Here, I'm not going to check what I put here. Instead of now me using the mutate function, I'm now coming to use the pivot wider function. And that is why I've already loaded. So I'll simply come here, enter, and say the pivot underscore. We have the pivot longer and the pivot wider. The pivot longer spec and then the pivot wider spec. Each of them have their places where they are being used. So the pivot wider, I'm just going to do that. That way, it allows us to be able to have names from what the values from, and then value field. So let me start with names from. So the name from, which particular name are we talking about? We are going to be talking about their sizes. So we say body sizes, right? So I'm going to say body underscore size. So I have body underscore size. And then the next thing we have names from, and then the next thing we are going to be looking at is what are the values from. So we have values. You see that we have values from and then values field. So here we are using values from first. Why are we getting the values from? We are getting the values from the value we have already created, which is called value. And then we have something called okay, if I leave it around this particular place, I can run it, but you're going to see that wherever the person body size is some way, it will either create it as 3 or something else. And because I have not specified the something else, it will give it NA. So let me run it and then you see. So you notice that it has created the small, the big, the plus size, the lanky people, and the medium. So those who are small are taking 3. If you are big, you take 3. If you are plus, you take 3. But if you're not plus, what do you take? Nothing is there. So you see that it is called NA. So it means we have to fill the NA with something. And that's why we need to fill in the other, parameter called values field. So we use something called values field like this. And what are we filling it? We are saying that, okay, if you are 3, it means you are small. But if you're not small, what value should we give to you? We can say, that, okay, we can say we should give you 0. And so it will replace all the NAs with zeros. And that's what I'm saying. So now if I run it, you can see that it has re-encoded everything into, now you can see my name there, you are single. When it comes to, you can see that it is 3. 3 means I am small. But the rest of the people are 0, 0, 0, 0. Then we come here, I am also 0. It means this person is also 0. And then you come here. This is what is called one-hot encoding. It's very, very important in, especially those who are doing engineering, and then those who are, into big time data science or deep learning and whatsoever. It's very important. If not, you might be tempted to think that once something has been described as small, and then something has been described as big, the big must come before the small. No, it's just description. It's not an ordinal. And so this is what one-hot encoding does. It's able to make sure that you don't, it diffuses data from being naturally ordered. And then you are able to have a very reliable model. If not, you build a model that will not be too reliable. Yeah. Okay. So that's it for today. That's the video for today. If you like it, why don't you give it a thumbs up, and then you subscribe to the channel. I will try tomorrow and then show another video of how to be able to apply this one-hot encoding in real life situation modeling. So we'll try and model something without the one-hot encoding, and then we come and transform all the data into this binary, and then we model it, and then you look at the model accuracy and see which one is having higher accuracy and which one is having lower accuracy. And that's when you can see the real importance of this. Thank you. See you tomorrow. Okay.